Hello, AP Statistics students. Sorry I couldn't be there today. I have to take my kids to the dentist, and it's going to take a surprisingly long time. But today we are not doing anything too difficult, but we do need to go over the precise procedures for the chi-squared test for homogeneity. So I've got an example worked out here. Just going to kind of scroll through it, and hopefully you can see all the specifics, and then you'll try one from an AP test a couple years ago to make sure you've got it. All right, let's do this. If you could pick any superpower, what would it be? Careful. Don't don't look at this picture too carefully. It's pretty good, isn't it? What team are you on? All right. Do you think children would answer this question differently depending on what country they are from? Independent random samples of children were taken from the UK and the US. The results of the survey are given in the table. So we did this one yesterday, and I just kind of wrote out sort of really good answers for all of the different pieces. So, of course, you start off with the state. We will test at the alpha 0.05 level. Your null is that there is no difference, but you can't just say no difference, okay? You got to make it sound good. There's no difference in the distribution of preferred superpower among children in the UK and the US. All right, just try to be as clear and complete of a description there as possible, and your alternative is that there is a difference in that distribution. Hopefully that's not too bad. The plan after that, the first two are the same. So the random condition is met. All right, grading the free response questions, I still have people not saying the condition is met. You have to somehow say that it's met. Because we have I forgot, my bad, independent random samples from the UK and the US. 10% condition, this one is the same as always. That one is also met because it is safe to assume that 200 and 215 are less than 10% of all the children in the UK and the US. Make sure you say that for every population that you've got, okay? Large count is a little bit different this time. So I grabbed a footnote from either our book or an AP study guide, I don't remember when, but stating the condition that the expected counts must be greater than 5 is not in itself sufficient. Okay? The condition must be checked by reporting expected counts or minimally reporting the value of the smallest expected count and indicating it that it is at least 5. All right, so how can you do this? Well, you could do it by hand. So if I take a look at this, the smallest expected count, well, 200 is the smallest population, and then the smallest total is 43, which means my smallest expected count will be right here. Now, it is a bit of a bit of a coincidence that that is also the smallest observed count, but it doesn't necessarily have to be the smallest observed count, I don't think. But to figure that out, it's now 200 times 43 divided by 415. So on 200 times 43 divided by 415. So our smallest expected count is 20.7. So our smallest expected count is 20.7. For super strength in the UK, which is greater than 5, so the large counts condition is met. All right. That is how we can satisfy the large counts. Now, if you don't want to do that by hand, you can go down to the do. All right, we're going to do a chi-squared test for homogeneity. You go to your calculator, you go into the matrix, all right, and you plug all the data into your matrices, right? Then we go stat tests chi-squared, AB calculate, All right, you could then do your conclusion, which I've got there, but I'm going to show some work for this here in a minute. But now that I've done the chi-squared, as I showed you last time, now your expected counts are in here. You can now you don't have to do the math yourself. You can now come in here and be like, hey, look, my smallest expected count is right there. So you don't have to do it by hand, but now you would, after doing the test, go back and say that, hey, we did meet the large counts condition. All right, so for the chi-squared test for homogeneity, you always want to report your chi-squared statistics. So our chi-squared, I think it was 6.29. Our p-value was 0.178. Our degrees of freedom was, I think it was 4, right? 1, 2, 3, 4. Yeah, degrees of freedom are 4. Remember, that's row minus 1 times column minus 1 for there. Technically, it would be nice if you could show me a couple of terms of the chi-squared test statistic. All right, so our first one would be 54 minus, what was the expected count? 47.7 squared divided by 47.7 plus, the next one is 45 minus the expected count, grab it off the calculator, 51.2 squared divided by 51.2 equals 6.29. They always call that out in the rubric at least a little bit. I'm not going to say you'd get docked for not putting it in. I'm pretty sure this is enough, but you'll help Bolt sleep at night if you do a couple of terms there. That would be swell. All right, then our conclusion, we talked about that, but with the p-value 0.178, which is greater than alpha, we failed to reject the null. We do not have convincing evidence. One last thing I'd like to do before I let you go work on some classwork here is interpreting the p-value. We've concluded from the p-value, but what does that p-value actually mean? It's been a while since we've written that sentence, hasn't it been? So first off, when you interpret a p-value, first you assume the null is true. So here's my sentence, assuming the null is true. Assuming that the distribution of superpowers among children in the US and UK are the same. That's assuming the null is true. Then that means, here's my p-value, there is a 17.8% chance we get a sample like ours. Okay, now to say that specifically, we get 2 independent random samples with a chi-squared test statistic. This is a sample like ours of 6.29. For chi-squared, it's always going to be greater. We always do the area to the right because of sample variability. All right, by random chance. It's been a while since we've written that sentence, but take a look at it. Alrighty, that's all I got here. What I'd like you to try to do is a free response question of your own. So in Teams, in the assignments, there's a PDF there for you, 2016 number 2. All right, do the full state plan, do conclude. Try it yourself. Once you think you've got it, go look up the answer on the internet. Okay, either Google, AP Classroom. You could find a YouTube video of somebody doing it, I'm sure, if you want to see somebody walk you through it. I have full confidence you can find the answer on the internet. Try that out. I will see you all tomorrow.